Good afternoon, everyone. If I could ask you to please take your seats, I think we're just about ready to get started. On behalf of Rice's Institute for Global Health Technologies and the Science and Technology Policy Program of the Baker Institute, it's really a pleasure to welcome our speaker today, Dr. Peter Hotez. He is the Dean of the National School of Tropical Medicine at Baylor College of Medicine, and also is a professor of pediatrics and molecular virology and microbiology at Baylor College of Medicine. He is the president of the Sabin Vaccine Institute and Texas Children's Center for Vaccine Development, where he and his group are leading a very exciting product development partnership to develop vaccines to prevent neglected tropical diseases. The human hookworm vaccine that was developed by his group is now entering human clinical trials. Dr. Hotez obtained his bachelor's degree from Yale University and then went on to earn a PhD from Rockefeller University and his medical degree from Cornell. He trained in pediatrics and pediatric infectious diseases at Mass General and also at Yale. He's been very active not only in clinical medicine and science, but also in public policy surrounding global health and the neglected tropical diseases. He is currently the president of the American Society of Tropical Medicine and Hygiene. He serves on the NIH Council of Councils and also on the Fogarty International Center Advisory Board. He's received a number of very prestigious awards for his work, including the Bailey Ashford Medal from the American Society of Tropical Medicine and Hygiene. He's also an elected member of the Institute of Medicine. So please join me in welcoming Dr. Hotez.
Well, thank you for that very generous introduction, Rebecca. One of the great attractions for coming to Houston was the possibility of partnering with Rice University because of all of the excellence in bioengineering. You know, vaccines in some ways are the black art of pharmaceutical development, and they've really lagged behind many of the small molecule drug discovery and drug development. And I think we're just at our infancy at really exploring how we can develop new delivery technologies, which would include nanoparticles. And so coming here was so exciting for us to be able to have this link with Rice University. And this afternoon we had a very special meeting with people from the Smalley Center and the IBB to really begin figuring out how we're going to forge those links. And I think this is going to be a very productive collaboration. So I'm thrilled to be able to have the opportunity to address you here today. And if I could, I'd like to acknowledge two very important people in my life. One is Dr. Mary Elena Bottazzi, who's the head of product development with us, and we've been working together now for 11 years on a lot of the things that we're going to be talking about today, so that's very special to have her here. And I'm really excited that my very busy boss, Mark Klein, took the time to come here and take some time out of his schedule. I appreciate that, Mark, very much. Mark, of course, is the physician-in-chief of Texas Children's Hospital and chair of the Department of Pediatrics. So this is not a huge group. It's a nice setting. I like the way the auditorium is configured. So I'm going to, at least for the policy part of the first part, since this is the Baker Institute for Policy, kind of make this a little interactive. At least in the beginning part, and we'll see how that works and whether we'll continue the interactive piece throughout the whole 45 minutes to an hour. And the way I'll start out my questions for you, and then we'll do this give and take, is you're going to first tell me how many people there are in the world today. 7 billion. And to see how good a job Dr. Richards-Cordham has done, how many people of those 7 billion live on no money?
About 3 billion.
So the the World Bank doesn't quite say live on no money. They say live below the World Bank poverty figure of $1.25 a day. And do I advance this way? No, it doesn't like me to advance. If I do it by here.
I'll just do it now.
Thank you. So they say there's 1.4 billion people who live below the World Bank poverty figure of $1.25 a day, and these are the urban slum dwellers. These are the subsistence farmers of the world. And you might have seen Paul Collier's book called The Bottom Billion, which I think is a wonderful book because it provides a nice framework for thinking about these problems, where we have 1.4 billion people living below the World Bank poverty figure, and there's a geography to that poverty, meaning that these individuals live on no money, but they also live in a part of the world where there's an inevitability about their poverty, meaning their children's children, their children's children are also destined to live in poverty. And then it was around the year 2000 where Kofi Annan decided to do something about the plight of the bottom billion and to really make a difference in the lives of these poorest people. And who was Kofi Annan? UN Secretary General. So what he did, where is he from?
Ghana.
From Ghana. So this Ghanaian Secretary General brought all of the global leaders to UN headquarters in New York and drafted this group of goals and targets to address the plight of the bottom billion for purposes of sustainable poverty reduction by the year 2015. So it had a 15-year time horizon. And I ordinarily I'm not so excited about United Nations documents. I think many of them are forgotten about as quickly as they're drafted. But this one has stuck. This one, when we still talk about international development problems, to this day, we put them in the context of these Millennium Development Goals, or MDGs. And we can just go through a couple of them. They include a very heavy component devoted to girls and women. Somebody finally figured out that addressing problems of girls and women are important to sustainable poverty reduction, which may seem obvious now, but believe it or not, it wasn't obvious then. So number 3 is to promote gender equality and empower women. Number 5, improve maternal health. And there was one that's specifically devoted to infectious diseases, and that's MDG number 6, which is called to combat HIV/AIDS, malaria, and other diseases. And this has made a huge impact in the lives of the poorest people because it's launched huge programs that are providing access to medicines for a number of infectious diseases. So maybe you can tell me about a few of the major initiatives that have been launched in response to MDG number 6 to lift people out of poverty. Don't be shy.
Rollback malaria?
Rollback malaria. So this is a United Nations program to put people on anti-malarial drugs and also provide large-scale access to insecticide-treated bed nets. And that's making a huge difference. Also developing artemisinin combination. So that all came out of this MDG number 6, the malaria component. Okay, you're on a roll. What else?
Polio eradication.
Polio eradication. That actually had started prior to that, but it's now been scaled up quite a bit in terms of the impact on. I was more looking around with respect to AIDS and malaria.
3x5 is one of them?
3x5, and then that was launched by Jim Young Kim at WHO to put 3 million people on antiretroviral drugs, and then the next generation of that became
Global Fund.
Global Fund. So the Global Fund to fight AIDS, they added tuberculosis and malaria, again, out of MDG number 6, to scale up antiretroviral drugs in addition to the antimalarials and bed nets. What about PEPFAR? Anybody hear of PEPFAR? What is PEPFAR? Anyone want to venture to say what PEPFAR is? So PEPFAR is funded You're paying for this. You should know about this. So this is Mark. What's PEPFAR funded to now as of this year?
It's about 30 billion in total over the past 8 or 9 years.
Right. And now it's getting up to close to $10 billion. So the whole President's Global Health Initiative, which is about $10 billion a year, includes about 70-80% for PEPFAR, so $7-8 billion a year to put people on antiretroviral drugs. And this is making a huge difference in the lives of the world's poorest people to get them on antiretroviral therapy. And so I don't know if you've had Dr. Klein here to speak to you, but he has created this extraordinary initiative called the Baylor International Pediatric AIDS Initiative, where Mark just celebrated a milestone for his program that he's now gotten 100,000 people on 100,000 kids on antiretroviral drugs throughout sub-Saharan Africa and Romania and elsewhere. And to see his pictures is just extraordinary, to look at the before and after of the huge impact on getting people, kids especially, access to antiretroviral drugs, kids and their families. And this is wonderful. And with it is attracted, and there's been a lot of collateral benefits as well. One of them is the fact that it's brought in a whole generation of global health celebrities who have been committed to the problems of HIV/AIDS and malaria. Now, tell me some global health celebrities.
Peter Hotez?
No, we're not there yet.
Angelina Jolie.
What's that?
Angelina Jolie.
Angelina Jolie, and if you get Angelina Jolie, you get... Yeah, so Brad Pitt just did a four-part series on global health. Who else? Bill Gates, yeah. Bill Gates, the Bill and Melinda Gates Foundation. Also for a research component, the International AIDS Vaccine Initiative and the Malaria Vaccine Initiative. Somebody else mentioned the big one. Bono, right. So Bono has had his one campaign. So, and with it has created a whole generation of young people interested in global health problems. I don't think I could have filled a room like this. Even 5 years ago, I would have had a lot of difficulty doing this. And it all reflects a lot of this energy. Now, the problem that we were facing after the launch of the Millennium Development Goals was this part, and that is these things called other diseases, because they actually call them the other diseases. And if you think about it from an advocacy perspective, it's really hard to get Angelina getting up there saying, now we're going to take on the other diseases. And so those of us who worked on other diseases realized, well, we're on the outside looking in on some very important global health initiatives. And when I say we, I mean myself and Alan Fennick at Imperial College London, David Molyneux, who was then the head of the Liverpool School of Tropical Medicine, Lorenzo Savioli at WHO. And we realized that we needed to do something because we recognized there was a very important group of other diseases that were being largely ignored. And so we started rebranding these conditions, and I'll go through them in a minute, as the neglected tropical diseases, or the NTDs, recognizing that we wrote the first paper with the word neglected tropical diseases in 2005. Now we're about 7 years into it, and we actually recognize it's not a great name, but now everybody's starting to know what we're talking about, so we're afraid to mess with it, so we're going to keep it the same for now. The point being, these are the most prevalent infections of poor people. About 1.4 billion people are infected worldwide, and I'm going to rank them now for you in order of what we think are the most common infections of poor people. So here's number one. Here's the most common infection of the world's poorest people, we think. What is it?
Roundworm.
It's Ascaris roundworm. So this little boy on the right has roundworms in his intestine. What's wrong with him?
Malnutrition.
He looks malnourished. That's right. What else? So this is easy. Yeah, he's got this big distended belly. You can run your hand over the surface of his belly and palpate the outline of intestinal worms. So this is a picture taken by one of my students in Haiti. So this is arguably the most common infections of poor people, and most of them are wormy diseases. So here's number 2 is whipworm infection that causes inflammatory bowel disease in the colon. Hookworms are hookworms that cause intestinal blood loss leading to anemia. 440 million people have schistosomes in their vasculature. 120 million people have filarial worms in their lymphatics and their genitals. This is one of the non-wormy neglected tropical diseases. It's trachoma. About 40 million people have blinding trachoma. 37 million people with river blindness caused by Onchocerca worms. 12 million people leishmaniasis, 10 million with Chagas disease, and these are the most common infections of the bottom billion. And the point is, every one of the bottom billion is infected with one or more of these neglected tropical diseases. And the consequences of that chronic infection is quite different from anything that we're used to when we think about infectious diseases here in the United States. And I use the C word to start out with. The point is being, these are chronic conditions, that people have these infections for not just a couple of weeks like you might have with a bad cold or a strep throat, but you have these for your entire lifetime. And during this period, they're extremely disabling. So this individual here with elephantiasis says it's quite a problem for me when I have to stand at work for long periods. And it's amazing how understated people can be when they have these conditions. So you can imagine how difficult it is for this person to go to work in the fields every day. Remember, these are the diseases of the subsistence farmer. So the losses in agricultural productivity are enormous. $1 billion lost annually by India. So India can lose up to 20% of its annual productivity. Remember, this is not a rare disease. We're talking about 120 million people in the world with this condition. These are the most common neglected tropical diseases, the intestinal worm infections, what's sometimes referred to as the unholy trinity of ascariasis, trichuriasis, and hookworm. And we have Alec Bhargava here from the University of Houston, who's done a lot of work on looking at the economic impact of these conditions and the nutritional effects as well. And just to give you a sense of what it means to have 800 million people with ascaris, I'm going to show you this study that we did a number of years back in Guatemala, where you can look at age class 0 to 3, 4 to 7, 8 to 12, and the prevalence, the percentage of these children that are infected with ascaris, trichuris, and hookworm. Maybe you can tell me what percentage of the kids are infected with ascaris worms here in the light yellow.
Don't be shy.
What percentage? They all are, right? Yeah, everyone's infected, right? And almost as many are infected with whipworm, the green here, and hookworms. The point being that you can do this exercise in any rural village in Guatemala, but you can do it in any rural village in Belize and Nicaragua and Honduras and El Salvador and Panama and southern Mexico. You can do this throughout South America, in Venezuela, in Brazil, in Peru, and Ecuador. You can go to Southeast Asia and do it in Cambodia, Laos, Vietnam, and Thailand. You can do this throughout South Asia, the Indian subcontinent, India, Pakistan, Bangladesh, 100% of the kids infected. You can do this in Angola and DR Congo, and do this in Sudan. And this is how you get to those incredible 800, 600 million people infected. And the consequences of this are extremely important. One is that children are disproportionately infected. So what I'm showing you here is a wormy curve, where you have age here on the x-axis and number of worms on the y-axis. And you can see that when you live in these endemic villages, whether it's in Central America, Sub-Saharan Africa, or South Asia, that children tend to have larger numbers of worms than adults, peaking in sometime in the middle of childhood and then tailing off. Why is that? Why are children wormier than adults? It must be known, right? The most common infections of people in the world. Why are children wormier? People are going like this, little kids put things in their mouth. That's a good hypothesis. Any others? Any other hypotheses?
Weaker immune system?
Immune system. So maybe as you get older, there's some kind of immunity that kicks in. Not classical immunity, because you still have worms, but not as many, so it's not sterilizing immunity. That's a good hypothesis. Any others?
Many of them die.
Actually, there tend not to be killer diseases. So that possibly that is a component to it. It doesn't seem to be so much. It's actually a trick question. Nobody knows. These are neglected diseases. So here we are, the most common infections of people in the world. We don't even know why kids are wormier than adults. And so you get this kind of situation like this little girl from Paraguay with the big belly, and these are the worms, these are the Ascaris worms from that one child. Now, that's a very dramatic effect, but what I think is a pediatrician, what I've been impressed with is the fact that these worms suppress physical growth. Here's age on the x-axis, here's weight on the y-axis, and you can see that this child has flatline growth until we intervene with a drug to get rid of the worms, and then the kid starts growing again. What's the basis of that? Alec, what's the basis of that?
Nutrient loss.
Good hypothesis.
It's not a hypothesis, it's a fact.
We have nutrient loss, but I don't know that we really know the true basis of growth failure in kids. We do know there's nutrient loss. We do know that there's some malabsorption with Ascaris worms. We do know that hookworms cause intestinal blood loss. Intuitively, I mean, I'm not disagreeing. Intuitively, I agree. There's probably some kind of competition host and parasite for nutrients. But in terms of the true mechanism, I don't think we really know. And I think it's still understudied. And I still think it's an open hypothesis for intervention, which is striking considering it's the world's leading cause of growth retardation. And it's not just the more worms you have, the more the worse, the less you're likely to grow. I tell my medical students this is the world's leading endocrinopathy. But the more worms you have, we have studies to show that the lower your intelligence is, the greater your loss in IQ. The worse you do in tests of cognition or school performance or even school attendance. What's the basis of that?
Do you have this figure with height instead of weight? Because that's iron loss. And
well, for hookworm, you're definitely getting iron loss, but why are you getting loss of intelligence and cognition?
well, that's of course the school intervention is important. I mean,
But what's the mechanism? What's the mechanism by which worms reduce your IQ?
Reduce school attendance.
I think there's something else going on. I think there's a biologic effect going on as well. But the mechanism is, from my standpoint, is totally still up for grabs in terms of understanding. The point being that these are neglected diseases. So here we have the leading cause of growth retardation, malnutrition, the world's leading cause of loss in IQ and cognition, and the amount of papers that really address the specific mechanisms by which this occurs is still wide open. So there's an enormous opportunity for looking at this in terms of mechanism questions. And there's this fascinating study that came out by Hoyt Bleakley, who's an economist who's looked at retrospective data to suggest that chronic hookworm infection in childhood reduces your future wage earning by 40%, probably because of the effects on intelligence, cognition, memory, school performance, growth. But again, the point being that these are the diseases that are trapping poor people in poverty. These diseases don't just occur in the setting of poverty, but they're actually causing poverty through their impact on child growth and development, intelligence, worker productivity. Now, there's one word I haven't used here to describe the impact of these parasitic diseases, which is usually the first couple of sentences that come out of any global health talk that you would hear. So if you were to listen to Dr. Klein talk about HIV/AIDS, it would be one of the words that he would use in his first sentence, or maybe his second sentence when he talks. It's sort of one of my thinking question. Mortality, right? So Dr. Klein gets up there, he says 2 to 3 million people dying every year, AIDS orphans, and everybody in that room understands why what he's doing is so important. Anyone hear a malaria talk in the last year? So the malaria people is the first thing they talk about. High rates of mortality. People they'll say things like, in the time we've been talking, 200 children just died of falciparum malaria. Nobody's dying here. So that when you're trying to convey the importance of these conditions as global health problems in terms of their impact on child growth and development, it's a long message. We don't have a good elevator speech that we can give to the policymakers, which is, of course, so important. What is an elevator speech?
Get your ID across in time it takes to ride an elevator.
That's right. So I actually had a elevator speech moment with Senator Brownback from Kansas, who invited me to come and talk to him. He goes, Dr. Hotez, thank you so much for coming to see me, but my staff didn't tell me you were coming. They we got our communications messed up. I have to go vote in the Capitol. Would you mind coming with me? And I said, of course, Senator, and I'll walk with you, and we'll talk as we go. And so you go on the little, if you've been to the Senate building, you go on the little underground train, and then you go up the elevator to the Capitol. So there you are. So what do you tell Senator Brownback? Well, he wants a number, right? And I don't really have, and we don't have a great number for people who can make a lot of influence, because we can't just talk about deaths. And this is one of the metrics that we've been using to describe these neglected tropical diseases with some success. It's called the DALY, the Disability Adjusted Life Years, the number of healthy life years lost either from premature death or disability. And it's by no means a perfect metric, and there's a lot of subjectivity and a lot of controversy about some of these metrics. But you can see that when we talk about neglected tropical diseases in aggregates, the DALY's sort of getting up there with what we would call the big three diseases: HIV, AIDS, malaria, and tuberculosis. And that is sometimes helpful. Just for kicks, what's another condition on here? It's high DALY's, low deaths.
Depression.
Yeah, unipolar depression. Isn't that amazing? In fact, Chris Murray from the Institute of Health Metrics and Evaluation now tells me that in the new version of it coming out soon, unipolar depression may actually rise to the top. So I think that's going to be another important field of global health, is looking at the global impact of mental health. So if you're thinking of what to do in the future to stay ahead of the curve, that's an important one. And then this concept of the neglected tropical diseases occurring in the setting of poverty, but actually causing poverty. And this is why it's so important that when we think about how to shape these problems from the policy level, that we don't just talk about the science, that we learn how to partner with social scientists, that we learn how to partner with the economists and the political scientists. The fact that these neglected tropical diseases impair intellectual and physical development in children, or reduce future wage earning, cause adverse pregnancy outcomes, reduce productive capacity, the point being that these are causes of poverty as well. And so let's just summarize what we know about the neglected tropical diseases. These are a group of 17 chronic major parasitic conditions, the most common infections in developing countries. They're just the opposite of emerging infections. What's an emerging infection? Give me an example of an emerging infection. SARS, right? We didn't know what occurred. Now it's a major crisis, and then it emerges very suddenly. What's another emerging infection? HIV was, right. So exactly. But these are just the opposite. These have been around forever. These are diseases that you can find ancient descriptions of these in ancient texts, in the Bible, the Talmud, the Vedas, the writings of Hippocrates, the Quran. They've been around forever, and during this time they disproportionately affect the world's poorest people, subsistence farmers and their families, high morbidity and disability. They tend to be low mortality, and then they promote poverty and interfere with economic development. And we've also now realized some new links with the big three diseases, HIV, AIDS, and malaria. So a very important one is schistosomiasis, which we used to call urinary tract schistosomiasis, because the eggs would get deposited in the bladder of people throughout sub-Saharan Africa, 440 million infections, so that if you would go into a rural village in sub-Saharan Africa and you ask the kids to pee in a cup and hold up their urine, here they're holding up red urine because of hematuria, because the eggs are causing granulomas in the bladder. And it turns out for decades no one had bothered to do a colposcopic exam on the girls and women with this condition. And now we realize that up to 75% of them have these same lesions on their cervix and uterus and lower genital tract, causing horrific pain and bleeding and stigma. And when people have bothered to look, now in Tanzania and in Zimbabwe, where the two studies have been done, this is associated with a 3 to 4 fold increase in risk of horizontal transmission of HIV/AIDS. And this is just a map of looking at the overlap between HIV/AIDS and schistosomiasis, and you can see, especially in southeastern Africa, there's quite a bit of overlap. So I think that's going to be an important news story to look at in the coming decade, the impact on female genital schistosomiasis promoting HIV/AIDS transmission. There are also a lot of important links between hookworm and malaria, and this is wherever you see the green here. This is a study we did with Simon Brooker showing that the hookworm infection geographically overlaps with malaria, and during that period of time in western Kenya, central Kenya, northwest Tanzania, you can look at hemoglobin concentration, and you can see that if you have neither infection, malaria alone or hookworm alone, you get a drop in your hemoglobin counts with either hookworm or malaria, but if you have both together, the bottom really falls out. So we're just now beginning to understand the collateral impacts of having dual infections as well. So that is some of the messaging that we've been using to get word out on why these diseases we think are so important. The other point on these neglected tropical diseases is that we can do something about them, oftentimes at very low costs, that we have greater difficulty doing with AIDS and malaria. And this was not discovered by Stephen Hawking, but it was discovered in part by his father, Frank Hawking, who was a tropical disease specialist who was working on people with lymphatic filariasis, elephantiasis, that disfiguring condition that I showed you earlier. He recognized that when people have this condition, the adult worms that live in the genitals and lymphatics produce eggs, but the eggs don't look like eggs. They look like little baby worms that come out in the peripheral circulation. In fact, they come out in the peripheral circulation at night, between 10 p.m. and 4 a.m. at night, which coincides with the biting habits of the mosquitoes. And Hawking and others did a lot of experiments trying to change the time around. They would change people's sleep-wake cycles, or they would put them on ships that would go long distances to see if the microfilaria in the peripheral circulation kept local time or the new time. And we still don't know the answer to it, but one of the things he was doing along with those studies is working with a drug called diethylcarbamazine citrate, or DEC, and he would notice that if he gave someone a dose of that medicine, it would really wipe out all of their circulating microfilaria in the blood, so that there weren't any microfilaria around for a mosquito to pick up and transmit from one person to another. So he hypothesized that maybe what we could do is, what if we gave the medicine out where we treated everybody at the same time through mass drug administration, treating a whole village at the same time? Would we lower everybody's circulating microfilaria load to the point where we can interrupt transmission? And he actually proved this in a number of villages in the South Pacific. And then he took it to Recife in Brazil, where he would actually mix the medicine up with the cooking salt. And while people were salting their foods while cooking, they were getting doses of the medicine, and showed he could eliminate lymphatic filariasis in Recife in Brazil, or in areas around it. And he published this in the Bulletin of the World Health Organization in 1967, which was read by Chinese parasitologists interested in their own lymphatic filariasis problem. At the time, in the 1960s, China had the world's biggest lymphatic filariasis problem. In fact, the whole life cycle was discovered off the coast in Fujian province in China. So this got to the attention of parasitologists in the late 1960s, and they brought it to the attention of Chairman Mao, who dictated that China was going to scale up Hawking's interventions like only the Chinese could. What was happening in 1967 in China? So the Cultural Revolution, what they did was they medicated the entire salt supply of eastern China with diethylcarbamazine citrate. What do you think happened? Somebody said something. Resistance. Hold that thought. No, resistance didn't happen, but we're going to come back to that. No, it actually worked. So China became the first country to eliminate lymphatic filariasis as a public health problem. And the WHO got very interested in this to say, well, maybe we can franchise it. If it works in China, why won't it work in the South Pacific? And it did. They actually did it by annual mass drug administration of diethylcarbamazine citrate to eliminate the disease as a public health problem in the South Pacific. Now, in sub-Saharan Africa, you can't use diethylcarbamazine citrate in sub-Saharan Africa. Anybody know why? Because it turns out if you're co-infected with another malaria-like infection called onchocerciasis or river blindness, it causes a severe reaction called the Mazzotti reaction. So what happened was people were upset because diethylcarbamazine citrate costs 0.4 cents a tablet. A box of 1,000 tablets costs $4. You can't get any cheaper than that. Well, what happened was the CEO of Merck was sitting on top of a discovery of a drug called Mectizan, otherwise known as ivermectin, where they showed that it was developed for veterinary purposes to deworm livestock. They were making a lot of money. It also worked for lymphatic filariasis and onchocerciasis. And an extraordinary gesture, the CEO of Merck created one of the first public-private partnerships for donating the medicine, so that ivermectin now became free for as long as anybody needed it for mass drug administration once a year, sometimes twice a year, but usually once a year annual dosing of ivermectin for your lymphatic filariasis or onchocerciasis. So now you have two drugs, one costing 0.4 cents a tablet, the other one costing 0 cents a tablet. And what do you think? How do you think the CEO of Pfizer felt when he heard the CEO of Merck was donating something? Well, he said, the CEO of Merck's donating something. Damn it, we've got to donate something too. And so he donated Zithromax. Anyone take a Z-Pack in the last year? What'd you take it for?
Allergies.
Well, hopefully you had something infectious going on. Or somebody thought you had something infectious.
Yeah,
but believe me, a lot of people use it for allergies, and as a result, Pfizer makes $1 gazillion off Zithromax. It also works for trachoma. So through mass drug administration, Morocco became the first country to eliminate trachoma as a public health problem. So what you're seeing are these enormous pockets of success through mass drug administration with drugs that are either very inexpensive or being donated. One of the most expensive ones is praziquantel for schistosomiasis, which is 8 cents a tablet because it's made generically. But even that could be kind of expensive because that would require 2 to 3 tablets, so that could be 24 to 32 cents. So what we began to look at is to say, well, how can we make this whole thing more efficient of mass drug administration? Because while we had noticed that lymphatic filariasis and onchocerciasis global coverage was reaching 50%, meaning that we were covering 50% of the world's people at risk for LF and onchocerciasis with either ivermectin or diethylcarbamazine citrate. For the STH stands for the soil-transmitted helminths, meaning Ascaris, Trichuris, and hookworm, or schistosomiasis, the global coverage was only 10%. So we were really not reaching, especially the kids, not reaching those who needed them. So this is a more of elaborate version of a map that we kind of drew out on a napkin in a bar in Geneva a few years back, and it's basically showing that there's a lot of overlap with these neglected tropical diseases. So you go into Sudan, where you have all 7 of these. You have Ascaris, Trichuris, hookworm, schistosomiasis, lymphatic filariasis, river blindness, and trachoma, or DR Congo, where you have 6 of them. What it meant, practically speaking, is that people are polyparasitized, that they don't just have one of these infections, they'll have multiple infections at the same time. So that if a person has hookworm, we actually have some studies that show that if you have hookworm, you're more likely to get schistosomiasis. And we notice that people have Ascaris, many of them will have river blindness or trachoma and LF at the same time. So knowing that, what might you do to make the whole thing more efficient?
Therapy?
Polytherapy, yeah, and combine them basically, and give it a cute name also. That's very important. And so we call it the Rapid Impact Package, and it's comprised of either albendazole or mebendazole, which is targeting a lot of the intestinal worms, diethylcarbamazine citrate or ivermectin, depending on where you are, praziquantel, and Zithromax. And now we have safety data to support giving albendazole, ivermectin, and praziquantel all at the same time. Not in a polypill. We're not there yet, but at least we could give them at the same time. And now Pfizer's working on some studies to show you can also fold in Zithromax. And look what we get for that. We get the most 7 common neglected tropical diseases: Ascaris, Trichuris, hookworm, LF, onchocerciasis, schistosomiasis, and trachoma. And we get some freebies too. We get strongyloides, foodborne trematode infections, teniasis, and scabies. And because the pharmaceutical companies are donating the medicines, or GSK is now donating 1 billion tablets of albendazole, for instance, our costs are extremely modest. We're now doing this in Rwanda and Burundi for 50 cents a person per year. So once a year, 50 cents a person. So the idea being, yeah, sure, don't stop giving antiretrovirals or antimalarials or bed nets. Those are life-saving interventions, but throw in another 50 cents an individual and look at the impact that you're going to make. And so we've now been working with trying to scale this up with USAID, that now has national programs of this in 12 countries. So these are national scale programs to treat an entire nation roughly around the same time. So this is going on in 9 African countries, 2 Asian countries, 1 Latin American country. And we even now created an organization to do this privately. We're trying to create a $100 million fund called the End Fund, End Neglected Diseases, in collaboration with a group called Legatum, which is an investment group. And we're doing this now in Burundi and Rwanda. And now I want to go to the videotape if we can. I don't know if you guys do that or I do that. Somebody's doing it. This is a promotional tape that we're doing for this. Very proud of our little worm in the globe here. And so as a result, of starting to scale this up now in a big way, we've now, there's been some very interesting World Health Assembly resolutions. The World Health Assembly is when all the health ministers come to WHO headquarters in Geneva. Do I do this or do we do that? To create elimination initiatives. So we're actually talking now through Mass Drug Administration about the possibility of LF, onchocerciasis, and trachoma elimination possibly by the year 2020 or sooner. And then for the others, we'll talk about in a minute. And then we're trying to promote a lot of advocacy. We don't have Angelina and Brad, at least yet, but we have Alyssa Milano is one of our spokespersons. Who's Alyssa Milano? Charmed, right, and who's the boss, and so she's been great in getting involved with us, and we're working a little bit on Share, and she's been distracted of late, and so so this is all very, very exciting. Now, and then we now think there's opportunities to link neglected tropical. This is a article we had, a policy paper we had in the New England Journal of Medicine out earlier this year about integrating neglected tropical diseases with HIV/AIDS, tuberculosis, and malaria to sort of link some of these big PEPFAR President's Malaria initiatives with neglected tropical disease control. So this is very exciting. So people are saying, well, I thought he was going to talk about nanotechnology. Where does that come in? Why is he talking about Alyssa Milano? So now you can ask your question. What's keeping me up at night when here I am being a prime mover of advocating for putting literally all of the bottom billion, or as many as you can, on once-a-year medicines through mass drug administration. Resistance, yeah, that's what would worry you. Amazingly, we've not seen resistance with diethylcarbamazine citrate despite some 30, 40 years of use. But what we have noticed, and really the evidence for resistance is really poor. Part of it is because nobody looks. That's a big problem, and we're trying to address that as well, to try to fold in programs of operational research to go along with it. But we have seen something with one of the benzimidazole anhelminthics that we use for hookworm. Now we know this class of drugs can rapidly achieve resistance when you do wide-scale administration for livestock, cattle, for sheep. And what we have found is that one of the major drugs we use for hookworm, mebendazole, does not cure and does not improve anemia, whereas albendazole still does. So this is just a forest plot that Simon Brooker showed how albendazole seems to improve anemia, mebendazole doesn't. And when Jennifer Kaiser and Jörg Utzinger did a meta-analysis, they found roughly a 15% cure rate for using mebendazole for hookworm. And the problem is it's so understudied that there's some people who say, oh yeah, mebendazole was always a lousy drug for hookworm. It never was a good drug. But people don't really know, because one of the studies shows that the more time you use mebendazole, the less and less efficacious it gets at curing hookworm infection. So we think we may be seeing the beginning of the emergence of mebendazole resistance for hookworm. So what do you want to do? What should I do? I'm actually genuinely asking this. What should I do?
Does resistance cross react?
We don't know. I think you have to assume it could. What would you like to do? If you had all the money in the world, what would you like to do?
Vaccinate them and give them initiate albendazole.
So a new technology. Anybody want a new drug? Another class of drug? Sure. Who would like another class of drug to have as a backup? Yeah, that'd be good. All right, so now I'm going to go to Andrew Whitty, the CEO of GSK. Say, Mr. Whitty, God, you've been amazing. You've donated 1 billion tablets. I know this has been a significant expense for you, and now I want you to invest X millions of dollars, and go back to your shareholders and tell them that you're not just donating albendazole, but you're going to embark on a major research and development program to make new anhelminthic drugs or new technologies. How do you think that's going to go over? It's not that the drug companies are bad guys. That's beyond the limits of what they can do to justify to their shareholders. So the point being that it's not just a matter of scaling up interventions. What we need is a parallel program for research and development. And that's been a really tough message to sell to the USAIDs of the world. And this is where we need good science policy to be able to educate Congress, educate not only the U.S. government, but European governments at the same time. And that's why it's so important to have a lecture of this type in a public policy institute, because it's not just the science, it's the policy that goes along with it. So this is, I think, the first time I've really presented it in this way. I've been arguing along the following lines. So in 2007, Bill and Melinda Gates, actually themselves, launched what they call an audacious goal in building a roadmap to eradicate malaria. And this generated a lot of controversy because people focused on his use of the E word here. How could you really eradicate malaria? And I am a little more forgiving. I think of it as, well, one, because he funds me a lot, but also because I think he thought of it more as an aspirational goal more than anything else. And what he argues makes a lot of sense. Yes, we have a moral obligation to expand the use of insecticide-treated bed nets, expand the use of IPT, enhance global procurement of artemisinin, but don't stop to innovate. In other words, in parallel, we need a very aggressive program of research and development for new drugs, I would argue new diagnostics, new vaccines, and new insecticides, that the two go hand in hand. You can't really do one without the other. So, and he's been able to make that case for malaria very effectively. So this is one of the first times I'm announcing that I think we should have an equally audacious goal for neglected tropical diseases. The idea being, okay, we've got now, through mass drug administration, we've slated for elimination lymphatic filariasis. We've eliminated it in 23 previously endemic countries. We've eliminated it in trachoma in 12 countries, river blindness in 2. I haven't even really talked about leprosy, but we've made great strides, and other very important neglected tropical diseases. So why don't we think about a new policy framework as an aspiration to think about eliminating all of the 17 neglected tropical diseases, which would include that global network for neglected tropical diseases, expanding MDA efforts across the U.S. government, the UK, bringing some of the emerging market economies. But don't forget this, an expanded R&D agenda, which is comprehensive research effort to give $1 billion for Rice 360 for improved diagnostic development in drugs, or to us for vaccine development, coupled with implementation research, and don't forget some of the basic research as well through the scale-up of international funding. So in a moment of what Alan Greenspan would call a rational exuberance, I wrote this policy paper for PLOS Neglected Tropical Diseases, which is a research agenda for the U.S. President's Global Health Initiative, and wrote this a couple of months ago, which basically said, all right, GHI, the Global Health Initiative, is spending $10 billion a year annually. What if you could set aside just 1% to 2% of that for research and development for new diagnostics, new drugs, new vaccines? What would that do in terms of putting new money into the system? It's actually $100 to $200 million. So put $100 to $200 million new dollars into the system. In the big scheme of things for making drugs and vaccines, that's not a lot of money, but that would make a big difference to the community of researchers in this country. And what I've now looked at the landscape of is not just thinking about new drugs, but developing a new generation of vaccines for the neglected tropical diseases that we don't think we're going to eliminate soon. So this is a paper that we just had in Health Policy called A Handful of Anti-Poverty Vaccines. I call them anti-poverty vaccines because they're vaccines that not only would promote health, but actually cause poverty reduction because of the poverty-promoting aspects of neglected tropical diseases. And this is what we've brought now to Texas Children's Hospital, which is the Sabin Vaccine Institute, which is a nonprofit institute that makes the vaccines that the drug companies can't make or won't make because they are destined for the world's poorest people. And the way we work is through establishing what's sometimes known as a PDP, a product development partnership, with our labs based at Texas Children's Hospital. But the reason we have this U.S. flag, the colors of Brazil, is to demonstrate our solidarity with the Brazilians, that we actually do the final steps of the manufacturing process in Brazil. So that the way it works is, when I started as an academic physician, I had, like many academic physicians, I had a lot of magical thinking that you discover a gene or a protein, and then you hand it off to the GMP manufacturer, as they're called, meaning good manufacturing practices. And from that, voila, a bottle of vaccine will suddenly appear. But what we had to learn, and this is what's taken us a long time, and what's now set up in the Feigen Center of Texas Children's Hospital, is this, that we have to show that we can make the material at some industrial scale, whether it's the 10-liter fermentation scale, the 20-liter fermentation scale, show we can make it the same way, purify it the same way each time, and develop this as a process that's documented in a quality system using something called batch production records. And it's quite different from what industry would do, because our cost effectiveness people tell us we have to make our vaccines for, in some cases, less than $1 a dose. So how do you do that? Well, it means using the most inexpensive expression vector systems. And that's what our group here of 15 scientists that came with us from Washington, D.C. to Texas Children's is doing, showing that we can use inexpensive expression vectors such as Pichia pastoris yeast or E. coli, high yield, high purity, using column resins that are also equally inexpensive. So we use the cheapy column resins whenever possible. In some cases, there are column resins that I used when I was a graduate student, some of the old ones that have gone off patent. And through this, we can develop a process making them at extremely low cost. And what we then do is we partner with the two major vaccine manufacturers in Brazil. So Brazil is enormous self-sufficiency for making its own vaccines. So one of them is called the Instituto Butantan, which has a snake for its symbol because it started making snake antivenoms at the turn of the 20th century. Now they make about 65% of Brazil's vaccines, the rest being done by an organization here called Fiocruz Biomanguinhos, and they've built this incredible translational research facility. So unlike our economy, which is having a lot of difficulties, the Brazilian economy is booming, and it's a country that we sometimes refer to as an IDC, an innovative developing country. Enormous biotechnology prowess, but then you can go a few hundred miles and go to endemic areas of the country where there's great poverty and high rates of hookworm. So we do our clinical trials in this unique clinic in Minas Gerais state where 68% of the population is infected with hookworm, 45% with schistosomiasis. So this is our list of our portfolio of guaranteed money losing products at the Sabin Vaccine Institute that we're doing, and now we're calling it the Sabin Vaccine Institute and Texas Children's Center for Vaccine Development right here in Houston. So we have a hookworm vaccine, which is a bivalent vaccine that's now going into phase 1 trials in Brazil. We have a schistosomiasis vaccine, and this is supported by the Bill and Melinda Gates Foundation and the Dutch Ministry of Foreign Affairs. Schistosomiasis vaccine is an interesting story. It began with initial support from the chairman of our board, who recognized that with all the infrastructure that we had with the Gates Foundation and now with Texas Children's, he could provide $500,000, and it can make a big difference to transition an antigen all the way through manufacture and maybe phase 1. So you don't need tens of millions of dollars through how we do things. And then the chairman of our board, his name was Mort Hyman, lived underneath he lives on Fifth Avenue across from the Metropolitan Museum. Who doesn't, right? And then he living upstairs from him was a Russian oligarch by the name of Len Blavatnik, who had water leaking into Mort's apartment. So Mort went to complain to Len, went to visit him in London to complain, and he said, look, I don't really care that much about the water leaking, but I want you to give me $20 million for Peter Hotez's schistosomiasis vaccine. He said, no, I'll give you $500,000 though, and he said, I'll take it. So now we've got $1 million and now some NIH support. So the idea is we can piece together funds. And we're now working with the Carlos Slim Institute to look at the acceleration of a Chagas disease vaccine. Do I have a few more minutes? 2 more minutes. So you're not going to give me much time to go into the science. Let me just say a few words about our hookworm vaccine. You can imagine if you're the CEO of a company, this is not the map that you want to see in your business plan, right, where you have North America in white, Europe in white, and all the countries in dark. How is it that you make a vaccine for hookworm infection? What we do is we target the blood-feeding apparatus of the worm. So what we've learned over the years is over a period of decades, we, and I mean our group, but also in partnership with Alex Lucas's group, who is with us and now at James Cook University, has discovered this fascinating array of proteins that the worm is used to feed on blood, including hemoglobin-degrading enzymes and heme-detoxifying enzymes. Well, we have found that they make a great vaccine. What happens is, I know you're not used to looking at CAT scans of worms, but this is a longitudinal section of a worm that's been hookworm that's been pulled out of an animal that was vaccinated with a protein known as APR1 involved in blood feeding. As the worm is feeding on antibody in the vaccinated animal, the antibody targets the gut of the worm. Remember, this is an animal, and interferes with its ability to feed on blood, so that the control animal's become severely anemic, whereas the vaccinated ones don't. And this actually happens to be a hemoglobinase, a protease. You don't want to inject people with a protease, so what we do is through site-directed mutagenesis, we've altered 2 canonical aspartic residues to an alanine. And what's nice about these enzymes is we've found that there's a subset of people living in the endemic areas who naturally make antibodies to these, and they're actually sort of like the hookworm equivalent of HIV non-progressors. They don't get reinfected with hookworm. So it's a nice convergence of evidence between the animals and the humans. And this is our clinical trial plan that we're doing now with phase 1 studies using the GST molecule, which is involved in heme detoxification. Then we add APR1, and then phase 2 studies in children. And we work with modelers to show that this would be the result of just having to deworm every year, because in the case of hookworm, they keep coming back, whereas eventually with the vaccine, we can really start affecting a dramatic downward slope to ultimately eliminate hookworm as a public health problem. We also have a schistosomiasis vaccine, because wherever we find hookworm, we find schistosomiasis. And the nice thing about schistosomiasis is there's a completed genome project. So not for hookworm, but for many other neglected disease pathogens, we have genome projects that are completed, and we've built on the schistosomiasis ones. It's where Alex Lucas with us has discovered this a very exciting tetraspan surface antigen, where we can, what's nice about schistosomiasis also, with schistosomes you can do RNAi, whereas it doesn't work for hookworm, at least in our hands, but you can give antisense RNA and prevent the whole biosynthesis of the outer membrane of the schistosome. So it appears to be essential to the integrity, and it makes a very good vaccine when you immunize a laboratory animal. I'll just say a word about our newest vaccine, which is a Chagas vaccine, and this was based on 2 antigens that were discovered not by us. This is our first vaccine where our group didn't discover the antigens. They were discovered by a man named Eric Dumontiel, who's at Autonomous University of Yucatan, and he's got these 2 very exciting antigens, TC24 and TSA1, that together give high levels of protection in laboratory mice. The intellectual problem that we're facing is, unlike hookworm and schistosomiasis, where we need high levels of antibody, in the case of Chagas disease, it's cytotoxic T lymphocytes and CD8 positive cells that are the effector part of the immune response. So it becomes a scientific hurdle of how do you reproduce these antigens in order to initiate and elicit CTL. So we have Bin John in our audience, who discovered a lot of these hookworm antigens and was very important in showing that these are antibody mediated, but for Chagas we need cytotoxic T lymphocytes. So what do? How do you elicit CTLs against recombinant protein antigens? Well, we don't really know the answer, but one of the exciting opportunities we think are putting them into nanoparticles. So we brought Michael Heffernan from Washington, who's with us now, where he's been putting antigens into nanoparticles together with polyinosine cytidine, which is a potent TLR3 agonist, and getting, with things like albumin, very potent CTLs and CD8 positive responses against those antigens. We'd now like to work with Rice University and look at how we're going to incorporate some of these antigens in nanoparticles. And we think that that's just one delivery mechanism to think about, but a very promising one as well. So I'll end here, which is that, and I'll bring it back to policy and the legacy of James Baker. And that is to say that many people don't realize that the oral polio vaccine that we all received as children was actually developed through unusual diplomatic channels. What had happened was the Albert Sabin, who was at Cincinnati Children's Hospital, had been working on the oral polio vaccine, and he had three strains for poliovirus type 1, type 2, type 3 that he knew would make a terrific vaccine. And at that time, Jonas Salk had his killed vaccine that was already in widespread use, and he was getting very depressed about the fact that he may never get his oral polio vaccine licensed. Well, the Soviets came to his rescue, because what was happening was, and this is in 1957, if you can imagine, at the height of the Cold War, right after Sputnik, that Soviet virologists came to see Dr. Sabin and asked for his help in scaling up polio vaccines for the USSR. So the Soviets got back channel diplomatic permission. Sabin got permission from our State Department to go back with the Soviet scientists, and that's where the vaccine was actually developed. And it was tested on tens of millions of Soviet school children, ultimately on all Soviet citizens under the age of 20, and that were the pivotal studies that led to licensure of the vaccine. So, and before it was brought back to the U.S. So it was an example of how two countries would put aside their ideologies for purposes of working together on vaccine development. And it's a term that I sometimes call vaccine diplomacy. So how do we franchise that one? And what's a modern day example? Well, one of the analysis we did is to show that 50% of the world's neglected tropical diseases occur in the world's Islamic countries, the Organization of the Islamic Conference, Indonesia, Bangladesh, the Middle East, Sudan, Pakistan, Mali, Chad, Niger. What are the opportunities there? Well, Indonesia would like to make a schistosomiasis vaccine. Iran has been experimenting with ancient technologies to make a leishmaniasis vaccine for decades. We think we have a technology that might be useful. How can we partner with the Iranians for purposes of making a leishmaniasis vaccine? How do you think this went over in the State Department? Actually, I didn't get thrown out. They actually think it's, in principle, it's a pretty good idea, but there are two problems. One, Iran's a non-starter. That's just too hot button for now, but maybe Indonesia. And the other problem is there's no money in the government. So it's not going to happen right away, but I think there are some definite opportunities. The other interesting piece of the analysis is another 20% of the world's neglected tropical diseases occur in the world's nuclear weapon states. Not so much the U.S., England, and France, but in India, China, Pakistan, North Korea, Syria, Iran. What are the opportunities then for partnering with these for purposes of taking? I mean, clearly they have the intellectual abilities to develop nuclear technology. Surely they have the abilities to work on vaccine development. So I think this could be something very exciting to explore in the future, and that's something that I'd like to do here with the Baker Institute, is to start thinking a little bit out of the box, as they say, about how we can work with nations, especially failed nation states, and some of the more controversial ones, maybe not axis of evil nations, that might be a little bit of a stretch, but some of the others to move forward that, I'm using that jokingly. So I'll stop there, and thank you for taking the time to listen.
We have time for just a couple of questions, and then we have a reception outside.
Yes, ma'am.
May I ask, you said earlier, and you showed it on the screen, that you got help from the Dutch government. How in the world did you do that? I know a lot about it.
Well, I don't know the exact origin. So the Dutch government actually put out a request for proposals for neglected disease technologies. And what we do know that in the case of the German government now has also done this, and now we've applied. And in the case of the German government, we know Bill Gates personally went to see Angela Merkel to persuade her to put out this RFP. The point being, the Gates Foundation can't be everything to everybody. He's going to need help. So my guess is at some level the Gates Foundation or Bill and Melinda themselves were involved in some advocacy in the Dutch government to persuade them to release this RFP. It's really great. For us, it was life-saving. And that's, our donors are very interesting now. Our donors are all about co-investment. That's the new buzzword. Nobody wants to do the whole thing. And so one of the great things about coming here now at Texas Children's Hospital is that they've made a very generous investment in our vaccine development program. We can say Texas Children's is now a co-investor. And that, you have no idea how many doors that's opened up now with Carla Slim and everything else. It's because if they feel, even if it's 1 to 2 or 1 to 3 or 1 to 4, it still lowers the activation energy required to get donors involved, and it's making a huge difference. So actually, our product development partnership is one of the only PDPs now embedded in an academic health center. So it's a whole new model for thinking about how to do things. Yes, sir?
Back to your polytherapy, I know things like albendazole would typically be given once a quarter. Are you saying once a year is really enough to long term?
It depends on the level of transmission. So certain levels of transmission, it seems to do it, but you still get into this problem as well, which is, in the case of hookworm, you can lower it, but then it comes back. So for lymphatic filariasis, onchocerciasis, and trachoma, we can actually, multiple rounds of therapy in many cases have been shown to eliminate the disease as a public health problem. It doesn't happen with hookworm, and it doesn't seem to happen with schistosomiasis. It keeps coming back, and so that's why we've argued we need a vaccine to do something like this. Yes?
What did you say in your elevated speech?
To Senator Brownback. Well, I mean, you talk about the fact that these produce a disease burden that's equivalent. Mark's going to hate this. Disease burden equivalent. I was in the elevator. A disease burden equivalent to HIV/AIDS and malaria, but look what we can do for 50 cents a person per year. And so we can have almost as great an impact as something like a PEPFAR, but for a tiny fraction of the cost. And again, the AIDS community has said a couple of nasty things about me in blogs, saying, Peter Hotez is, doing this to the detriment of the HIV/AIDS community. But what I'm always very careful to say is we should absolutely be putting people on antiretroviral drugs. I mean, I worked in a pediatric AIDS clinic for a decade at Yale, and nobody, like me saw. This is before we had a lot of medicines available. We only had AZT, and I was able to witness firsthand the suffering of a kid with HIV/AIDS. So the point being, it's not either or. We're saying give it as a small add-on cost to PEPFAR, and now we're making links between the two. And it's starting to get attention of people like Eric Gooseby, who's head of the President's Emergency Plan for AIDS Relief. But there are some policy barriers as well that have made it difficult. And then the harder part of the elevator speech is, unless the elevator gets stuck, I don't have the speech quite homed in on the whole research and development piece, which from my view is just as important.
So I think if there are more questions, we'll take them at the reception. I'd like to invite everyone to join us to the reception.
Thank you.